Welcome! You are watching a RobotStudio tutorial developed at University of Skövde, Sweden. At the end you will find links to more educational resources. In this tutorial we will look at how to jog the robot. In RobotStudio it is possible to jog the robot in different ways, but before we start jogging the robot, we will have a quick look at the robot's links and joints. Then we will explore the freehand functions for jogging. The freehand jogging is used when the exact location for the tool center point or the robot is not required. When we need to jog the robot in more detail, there are two other alternatives. Mechanism joint jog for jogging joints, and mechanism linear jog for jogging the TCP in a linear mode in relation to the selected coordinate system. But it can also be used for reorientation of the TCP. Mechanism joint jog and mechanism linear jog can be used to jog any kind of mechanism. Here we see an IRB Robot 140 with the tool attached. All objects in the graphics window are also available in the window to the left in the Layout tab. On top we find the name of the station, Jog Robot. Under Mechanism we see the robot and the tool. And if we right-click on an object like this, the context menu opens, and here we find different functions related to the selected object. Let's try this visible. If we click on the small arrow to the left in front of the robot name in the layout browser, the robot object is expanded and we see a folder with the links. If we click on this small arrow, we see all the different links of the robot. 7 links, a base, link 1, link 2, link 3, link 4, link 5, and link 6, which is the mounting plate to which tools are attached. And it's also good to know that links 1 to 3 make up the robot arm, and links 4 to 6 make up the robot wrist. The joints, however, we cannot see, as they are located between the links and are used to control the movements of the links. As there are 7 links, there are 6 joints, all rotational joints for this robot. So by controlling the movements of the joints, the desired movement and location of the TCP can be realized. And now we will start to jog the robot, and first we will have a look at the freehand functions for jogging. Up here in the freehand section there are some different icons. The first 2 are for moving and rotating objects. The next one is for handling physics-enabled objects. And then we will look at the following 3, the jog joint, the jog linear, and the jog reorient operations. And there is also one operation to jog several mechanisms at the same time, multi-robot jog. So if we left-click the jog joint icon, then in the graphics window we can left-click and hold, and then just drag a link in different directions, and then we see the name of the associated joint and how much it is rotated. So here we see in the positive direction, and this is actually in the negative direction. And if I select this link, I can rotate this one. So this is the third link. And then we have the wrist, the fourth link, the fifth link in between here, and finally we have link 6 here to rotate the mounting plate where the tool is attached. So the jog joint operation is for jogging joints one at a time. Then we'll have a look at the next jog linear, and with this one we can actually move the TCP, the tool center point, in a linear mode, in a straight line. So if I left click and hold any of these arrows in this coordinate system, I can move the TCP in a straight line. Of course, only within the reach of the robot. And at the same time as we jog linear, we see the different values for the TCP in the X, Y, and Z parameters. And then finally we will have a look at the jog reorient operation. Here we can reorient the TCP, and as the same manner as before, I can just left click and hold any of these blue, red and green arrows here, and I can see how the TCP is reoriented. And at the same time I can see the values for the location of the TCP. This is also a very convenient function when the robot arm or wrist may interact with some other object. Then I can actually change the location of the robot arm or the robot wrist to avoid collision with other objects. So all the freehand functions here are only used when we do not need to position anything with high accuracy. When this is required, there are some other functions that we will have a look at. And if we right click the robot in the layout tab in the window to the left, open the context menu, then we can first select mechanism joint jog. With mechanism joint jog, we can jog each joint in very high detail, and there are some different ways to use these functions. We can select or click on the arrows to move each joint at a time. Joint 1, joint 3, 4, 5, and finally joint 6, the mounting plate. And we can also select the ruler and drag and hold this one to rotate a joint. And for the highest level of detail, we can, when we have selected the ruler, just type in the value on the keyboard like this. So if I enter 0 for all the joints here, I can use very high detail for each joint. And down here I can also see the configuration values for the robot. I can see the location of the TCP, and when using these arrows to the right in this joint jog window, I can set the resolution here, the step resolution for each time I click on an arrow. So here we only change 1 degree for each time we click an arrow. If I increase here, each click means 5 degrees rotation in any direction. And finally, we will look at how to jog the TCP in aligner mode, or how to reorient the TCP with higher accuracy. First, we'll close the mechanism joint jog window. Then we right-click the robot name in the Layout tab in the window to the left. And then we select the mechanism liner jog. Here we can move the TCP in aligner mode, either in the X, Y, or Z axis. And as we can see here, it's the word coordinate system, which is the reference coordinate system now. If I need to change, I can do this here. And I can also set the resolution for when using these arrows. The millimeters is for when moving the TCP in aligner mode, degrees when reorienting the TCP. So if I click on these arrows, I can see that the TCP is moved in aligner mode in either X, Y, and Z axis. If I would like to reorient the TCP around the X, Y, or Z axis, I can use these arrows. And below I can also see the actual configuration values. If I know the exact location of the TCP, I can enter these values directly here. And finally, if I would like to get back to the starting configuration for the robot, I can right-click the robot name in the Layout tab, select Move to Pose, and here I select Jump Home. So this is actually the starting configuration for the robot. And now it's time for you to exercise to jog the robot. Thank you for watching.